A polar equation is an equation where our variables are r's and thetas. And so two examples above me that I have are in rectangular coordinates, x's and y's, and we want to convert those to polar coordinates, or polar equations. And so x plus y equals 5, I hope we recognize that as a line, and we can represent that line in polar coordinates. And likewise, x minus 1 squared plus y squared equals 1. That looks like a circle of some type, and we can recognize, or we can go ahead and convert that to polar equation or polar form as well. So x plus y equals 5. Let's convert those to r's and thetas. If we remember that I have a model right here, x equals r cosine theta. So I have r cosine theta plus r sine theta equals 5. I can factor out an r. I'm left with cosine theta plus sine theta equals a 5. Divide both sides by cosine theta, cosine sine theta. So I have r equals 5 over cosine theta plus sine theta. So this equation in xy world is the same equation in polar world. And I was able to convert one to the other. This one, a few more steps. The steps aren't complicated. We're just doing them in polar world a little bit. So let's convert all my x's and y's over to polar world. So x was again r cosine theta. So r cosine theta minus 1 squared plus y, which is r sine theta squared, equals a 1. And let's see if we can go ahead and reduce that down a little bit. So r cosine theta minus 1 equals r squared cosine theta squared minus 2 cosine theta plus 1 plus r squared sine theta squared equals 1. Again, this wasn't, it looks different because it's in using our trigonometric functions. If it was back in how we factored in 111, it would look a little bit more familiar. So I'm hoping this is becoming familiar to you as you continue your practice. Let's combine our terms a little bit. Let me put my r squareds over here. So I have an r squared cosine squared theta plus an r squared sine squared theta minus 2 cosine theta plus 1 equals 1. Whoops, plus 1 equals 1. Let's factor out an r squared here. So r squared, and I have a cosine squared theta plus sine squared theta. I hope that looks familiar. Minus 2 r, whoops, there's r right there. 2r cosine theta, 2r cosine theta plus 1 equals a 1. R squared, this just becomes a 1, so that's an r squared times a 1 minus a 2 times an r times a cosine theta plus a 1 equals a 1. Let's, we can take out an r. So I have an r, and I'm left with an r minus a 2 cosine theta plus 1 equals 1. I subtract 1 from both sides, so I'm left with r times r minus 2 cosine theta equals 0. And so I know that is true when r equals 0, or the other one when r minus 2 cosine theta equals 0. And so those two particular cases are true. Well, sorry. Yeah, when r equals 0 or that equals 0. Solving this for r over here, this is true. Oh, sorry, I was already solved. R equals 0. This is true when r equals 2 cosine theta. I know that the point where r equals 0, its radius equals 0, is at the point, it's at the origin. And so I know that this equation right here, r2 cosine theta, also includes that particular point. So I don't need to include this in my final equation. So if I were to transform this equation in xy world, it transforms into r equals 2 cosine theta. And there you have the transformation from xy world to polar world. And I know that was probably a couple of big steps for us. So I get it if this one's going to take some time to practice. But I wanted to at least show you an example of kind of how the process unfolds.